It's just a little after 11. I'm Andy Malice. I'm going to be chairing this combined IETF 112 PALS, MPLS, and DetNet session. The session is being recorded, as are all of these sessions. As I said, I'm chairing. Stuart and Tariq are my co-chairs for this session as well, although I'll be doing most of the heavy lifting in terms of the slides and moderating the speaker queue and so on. Our working group secretary is Dave Sinacrope. Dave, thank you very much. Dave put together the agenda, and Dave will be taking the minutes for the session as well. And by the way, the minutes are available on etherpad/hedgedoc/codeimd, whatever they're calling it these days. So please, if you'd like, you can watch along, and you can even type in to help out with the minute taking, which will be done live in the etherpad/hedgedoc. Okay, with that, I'm going to go on to the next slide. This is the note well. This is something that you've all seen before, and so I don't think we need to go into it in any great detail. So the purpose for this meeting, this is a joint session of PALS, MPLS, and DetNet. This is the third such meeting that we've had since IETF 111. We're discussing basic architectural issues that have arisen from drafts that are proposing new applications and uses at the bottom of the MPLS label stack. And that was actually the initial intent, and it's kind of grown from there. And if you were in the MPLS session last period, then you got to hear Loa give a really good summary of how we're coming along and where things stand right now. So I highly recommend, if you weren't in the MPLS session previous, that you go to the meeting materials and you look in the MPLS session and take a look at Loa's slides from the last session as well. So a quick overview of the agenda follows right here. I'm actually not going to read it because the next slide is going into the agenda in much more detail. The open design team work has not completed. We will be continuing the open design team calls following this IETF meeting. Okay, so next slide. So this right here is the meeting agenda. I have preloaded all the slides into MeetEcho. So for the speakers out there, I will be running all the slides, and when you want to go to the next slide, just say next slide and I will switch it. But I'll be doing all the projecting, which is much easier than switching it to each of you individually. So I'm doing the chair's intro right now. Next, we'll be having Matthew, who'll be speaking about requirements for the MPLS label stack indicators. Then we'll have Balaz giving us an update on what's happening with DetNet and DetNet's use for the ACH. Then Karidi has two talks, one after the other. The first on the MPLS first nibble, and next on the special purpose label. Now we have 30 minutes allocated to Karidi's two talks. And what I'm going to let Karidi do is basically manage that time himself. So as long as Karidi stays within the 30 minutes, he can feel free to switch from one talk to the next talk when he feels comfortable to do so. Then we're going to have the network function indicator from John Drake. We have 20 minutes of open discussion time allocated on the agenda. So what we'd like to do is, during the talks, when presenters are actually presenting their slides, if people could just ask questions for clarification only and not start to argue points or make points of your own. What we'd like to do is table that kind of discussion for the open discussion period following the presentation of the slides, especially because you may find that if you have a question or a comment, it may be taken care of in a subsequent slide, either from the same presenter or from a subsequent presenter. So we'd like to ask that you keep your major discussion points for item 7 on the agenda. And finally, Stuart is going to be listening along. He's going to be taking notes, and then at the end, we're going to give Stuart 10 minutes to basically summarize what's been going on, what he's heard, and what we would like to do going forward. So with that, First of all, do we have any questions on the agenda, or any comments that people would like to make right now before we get started? And I'm not seeing any hands raised, so let me move on to my last slide. These are the online resources for the meeting. So this is URLs you can click on for the agenda, of course, to get directly to Etherpad, or of course, you can get there via the IETF agenda page as well. You'll notice on the left, of course, in MeetEcho, there's the notes section or the discussion. That's exactly the same as the Jabber room for pals. So you can monitor the Jabber discussion either way, either directly in MeetEcho or via your favorite Jabber client. We also have an Open Design Team wiki for the MPLS Open Design Team group. So I'd like to point you at that, and the wiki is always there. If you have any questions about what's going on in the design team, you'll probably find your answers on the wiki, so you can search there first. If you have any issues with MeetEcho, the meeting audio or so on, send an email to support@ietf.org, and they will have someone help you. And we also have a MeetEcho tech who's monitoring Jabber for this session and for all sessions. So with that, I'm going to switch to Matthew's deck. So if you wait 1 second.
Thank you,
Here
Andy.
we go.
Yeah.
And Matthew, take it away.
Thanks, Andy. Hopefully you can hear me.
Yes, we can hear you great.
So this first presentation is about the requirements draft for MPLS label stack indicators for ancillary data. So this is something that I've been editing along with Stuart, who's been helping. Thank you. And next slide. So this draft specifies the requirements for indicators in the MPLS label stack of ancillary data that exists below the label stack. And the intention is that this will be a product of the MPLS Open Design Team. This is version 0 of the draft, so this is just this is the first revision of the draft. And the intention is that it's going to describe the behavior of the protocol mechanisms and procedures. So just to be clear, this is not implementation requirements. And we want to be able to identify the toolkit for these requirements and any new protocol work that's required. The primary objective of this is to avoid piecemeal solutions to different emerging applications for these indicators in the MPLS label stack. We want to be able to ground the work very clearly on the existing MPLS architecture. Next slide. So we kind of started by trying to define some terminology in the draft, and the two key things really are ancillary data and what an ancillary data indicator is. So we propose that terminology for ancillary data is data relating to the MPLS packet that may be used to affect the forwarding or other processing of the packet. And this can be done at either the LER or LSR. And it may be implicit, so it's implicit in the context of the LSP or flow, encoded within the label stack. So it's actually explicitly encoded as in-stack data in the label stack. Or it's after the bottom of the label stack, but not considered part of the payload, or it's within the payload. And we need an ancillary data indicator. So this is an indicator in the MPLS label stack that ancillary data exists in the packet. It could optionally also indicate the specific type of the ancillary data. Next slide. So I've kind of summarized some of there's a couple of pages of high-level requirements in the draft as it stands, and I've clustered these together on the next few slides. I've only called out the key ones from the draft. A lot of these requirements were kind of gleaned from discussions in the Open Design Team or from some of the existing proposals for solutions. So what we've tried to do is to take those sort of protocol specific requirements in those and generalize them. So this first slide on the requirements is a set of architectural principles. So the first one is that MPLS combines extensibility, flexibility, and efficiency using control plane context combined with a very simple data plane to make forwarding decisions about the packet. And we want to maintain those principles. So any solution must maintain these properties of MPLS. Any solution for this also must not restrict the generality of the MPLS architecture. So it must be applicable across multiple different applications, multiple different domains, multiple different use cases for MPLS. It must be able to coexist with and not obsolete existing MPLS mechanisms. So we're not looking to obsolete the existing MPLS data plane and control planes, for example, and it needs to work to some extent, at least in an existing network which uses existing control planes and data planes. Ancillary data indicators should make use of the existing MPLS data plane operations. We recognize it may require extensions to the MPLS data plane, but they mustn't be inconsistent with the MPLS architecture that is defined in RFC 3031. Next slide. So now there's a set of protocol capability and backwards compatibility requirements. So this is really about, defining the requirements for capability advertisements, capability negotiation procedures, making sure that bad things don't happen. For example, ADIs are not delivered to nodes that cannot process them and then start discarding data, for example. So the first one of these is that neither an ADI nor these ancillary data must be delivered to a node that is not capable of processing it. And care needs to be taken in the coexistence of ancillary data and existing post-stack data mechanisms. So, for example, things like the GACH. The mechanism is required to enable an LER to insert ADIs or inserting ADIs to determine if the far-end LER can accept and process a packet containing a given ADI. Next slide, please. So then there's some sort of high-level requirements for the protocol development work. So any solution needs to accept the principle that special purpose labels are the mechanism of last resort. So the reason this is in there is that we have a very limited pool of free special purpose labels we can use, and ideally we're trying to avoid either allocating special purpose labels per application, which is part of the reason we're doing this work. Ideally, we'd like to avoid allocating any special purpose labels for these protocol mechanisms because it's such a limited pool. Let's look at other mechanisms first. The mechanism to indicate the ancillary data must operate in the context of the top of stack LSE. So the idea of this is basically in MPLS today, typically an SR will look at the top of stack and will make a forwarding decision based on the top of stack. So we don't want to break that principle with this with ADIs. The mechanism is required to enable an LER inserting ADIs to determine whether LSRs along the path can parse the label stack and process the ADI at the location this is inserted. So this is really saying you need to insert if you're targeting an ADI for a particular downstream LSR, you must be sure that it can actually parse the label stack to a sufficient extent to be able to read that ADI. We need to be able to support this for point-to-point and point-to-multipoint paths, but we only expect a specific ADI to be supported for one or the other. Data plane mechanisms for ADIs must be independent of the control plane type, so it should work with LDP, RSVP, BGP, static labels, IGP advertised labels, and so on. So basically anywhere where you can use the MPLS data plane today. A mechanism must be defined for the control planes to be able to determine the ability of downstream LSRs and ADRs to accept and process a given ADI. And it should be possible to include indicators for ancillary data for multiple applications in the same label stack, but each ADI only supports one application. Next slide. Okay, and we started to write down some security requirements as well. I'm not a security expert, but I've seen some of this work go on in other working groups related to what you can expose within an outer or underlay protocol header, based on what it's carrying. So there's a couple of requirements in this draft as it stands. So the first is that the solution must be provided to verify the authenticity of ancillary data processed in the LSRs. And the design of the ADIs and the ancillary data must not expose confidential information to the LSRs. And this is in there because there may be confidential information in the payload that potentially could be used to generate an ADI. But obviously you don't want to expose anything that's actually confidential about that information in the underlay network. Next slide. Thank you. So the next steps to clean up any duplicate requirements in the draft, we'd like to continue to gather requirements from emerging applications, and also there will be some kind of companion architecture and framework document, I think, that will exist that will hopefully help to drive some of the requirements. And we would really appreciate some review and feedback on the list and into the open design team. Thank you.
Okay, thank you, Matthew. And I see that Tweety has his hand up. Tweety?
You hear me, right?
Yes, I can hear you now.
Okay. There were a couple of comments I had on previous slides. One, that we should use the special purpose labels as a last resort. I think that one, first of all, we've been using special purpose labels for other things, but especially, and I know that this is a specific solution, but the FAI approach essentially lets you use one special purpose label for lots of things. So I think that sort of parsimony of special purpose labels can perhaps be, pull back a little bit if you say that when you do the special purpose labels, you try to do multiple things with a single special purpose label. So I think that ability for a special purpose label to carry many more functions and many types of ADI. If you were doing one ADI per special purpose label, yes, I'm totally with you. But given a new mechanism where a single special purpose label can be used in a multi-purpose fashion, I think that requirement, and especially the term last resort, I think is something that we should rethink. So maybe you can soften that by saying, if you're trying to do one special purpose label per type of ADI, then it absolutely should be a last resort. But if you can carry multiple types of ADI with a single special purpose label, then that becomes a valid solution. Does that make sense?
Yeah, I think that makes sense, because of course what we're trying to do here is to provide a framework or a mechanism that will work for many future applications for ADIs. Presumably if we can have one special purpose label, we're not going to be replicating multiple different special purpose labels.
Yeah. And could you go back to that slide and the slide before it, because I had a comment on the previous slide too, but I have to.
Let's see. That slide there?
No.
How about that one?
No, it's not this one. Okay, maybe I'll look over this. Oh yeah, this one. Yeah, thank you.
Okay.
Yeah. So neither an ADI nor ancillary data must be delivered to a node that's not capable of processing it. when we did ELIs, we said, hey, we will ship this. If someone can handle it, great. They can do a much better job of load balancing. If they can't, okay, there's no harm, no foul. And I think we have to be careful that if we classify ADIs into, if you see this, you must process it. And if you can't process it, drop the packet. Then I would go with this particular thing that ideally you don't even deliver it to a node if you know that it can't process it.
Well,
The next
so,
one,
sorry, Preeti.
sorry, let me just finish. But if it was like this is an optimization, if you can process it and do better with the packet, go for it. If you can't process it, no big deal. And so that distinction, for example, let's say that a slice identifier is really important. You want that end-to-end guarantee for that slice. And so if you send it to a node that doesn't understand it, then bad things will happen. Then you really don't want to send it to that node. So I think that first bullet may have to be softened as well.
Okay. Preeti, I'm going to have to interrupt because we are getting along in the agenda.
Sure.
I'd like to ask if you have any further comments. Keep them for the discussion area, or take it to the list.
Okay.
Great, thank you very much.
Your audio is breaking up terribly. I'm not sure whether you've done something to it since we first started.
No. Let me see 1 second. Okay, how is that now?
No, it's still breaking up. Well, maybe it's just me, but it's still breaking up.
No, might be my headset.
It's terrible.
Yeah.
Okay, I'm gonna-
cracking noise.
Okay, I'm going to switch to my laptop microphone. Can you hear me now?
Much better,
Yep.
much better. Thank you.
Okay, very good. I'll just use the laptop in that case. Okay, very good. Thanks for letting me know, by the way. And now what we're going to do is we're going to switch to the next talk, which is going to be Greg. So let me switch to Greg's slides.
Thank you.
And that should do it. Nope.
Thank you.
Nope. Wrong slides. Wait 1 second.
No, that was right.
Oh, wait 1 second. So it disappeared. So wait 1 second. Let me make sure that I have the right one. Greg Mirsky. Okay, there we go. Okay, great.
Thank you, Andy. Okay, so this is resulting from our discussions in DetNet on OEM for DetNet over the MPLS data plane. Next slide, please. So there, deterministic networking data plane, we are working with the MPLS and IP. And for MPLS, the two sublayers been identified. It's a DetNet service sublayer and a forwarding sublayer. So for their procedures, we are using their pseudowire architecture, and for their DetNet service sublayer, need to use the sequence number, and DetNet flow identified using the label and their sequence number in a control word. So that's why we identified as a DetNet control word, and the use of DetNet control word in is mandatory. Okay, so on this figures, you can see that effectively what we have is that DetNet is using multi-segment pseudowire approach. Next slide, please. So in the figure, we just remind how their encapsulation looks, and we have a label stack, then S label that identifies their DetNet flow, and this is the bottom of the stack label, and that immediately follows the DetNet control word. So that's takes care of their data traffic. Next slide, please. So in control word, the first nibble is all 0, and then it follows using their sequence number. And the sequence number is critical for DetNet because in the service layer, nodes, dedicated nodes, can be placed with a packet replication, duplicate elimination, and order preservation functions, subfunctions. And for duplicate elimination and order preservation, the sequence number is critical, essential. So thus, the payload must have the sequence number. And the sequence number space is circular, and monotonically increasing. Okay, next slide, please. So here you see the service layer being presented, service sublayer DetNet, where we have placed replication point, duplicate elimination, and ordering. So the pre-off, as an acronym for all these mechanics that used in a service sublayer, is effectively per packet proactive protection. So it might look similar to 1+1 protection, but in the classical 1+1 protection, their destination selects one source to receive the packets. Whereas with the pre-off, what happens is that packets being replicated at replication by replication function, and then they will travel on disjoint paths. At somewhere there will be an order preservation and elimination functions. So the elimination function is just to eliminate unnecessary copies. So thus, in the DetNet domain, we can achieve, we can decrease their packet loss. Next slide, please. So the OEM for the service sublayer is important, and what we have considered, we considered to use ACH and use reserved field as a sequence number, so that OEM packets can be processed in a way similar to the data packets and by the pre-off replication, elimination, and order preservation functions in the domain. But then when we started looking, and we found is that we need some more functionality from their DetNet ACH. Next slide, please. And what we are considering now is that, again, so what is being presented today is only individual draft. It's not yet been discussed by DetNet working group because our meeting, I believe, on Wednesday. So you can see here is that new format for DetNet ACH. So the first nibble still is 1. but version is 1 as well. So we are taking the next version number, and it has a sequence number and a channel type. And then the second 32-bit word is used for note ID and some other fields that we still thinking of how they're interpreted, but we just put the level flags and the session identifier for placement. So, but they might be considered for now as reserved as well. But in general, so what we're proposing is we're proposing to change to take a next step from ACH as defined for the pseudowire, and that was previously up to now defined in DetNet working group document as 132-bit word, and using the versioning extend their applicability and use of DetNet ACH. And I'll probably pause here to see if anybody wants to have a discussion about it. Yes, Kiriti.
Short. Is that a good enough sequence number?
Yes, that might be not good enough, and that's a very good question. So what might happen, and again, that we'll discuss in more details in DetNet group, is that the sequence number will be moved to their second word, and that space can be reused for some other elements that we think that are needed in a DetNet service sublayer. Because the reason why we introduced this new format, and it was because of our analysis of service sublayer in DetNet and MPLS.
So I'm happy to hear that, because one of the things that I was thinking is that that space of the first nibble is really short. And, that first nibble came from a hack, and I'll talk about it in my section. But I'm thinking that we need an extension field that says, here are subtypes. So if you say 001 is a DetNet OAM, then you could say I have subtypes of the DetNet OAM, and so extend the space that way, as opposed to try to live within that really small space of just 16. So I think there are ways that we need to think about this so that we can really use that MFN, the first nibble, more effectively.
Mm-hmm. Yes,
but it's worth.
Yeah, actually, what we are taking advantage here, and that's might be a good recommendation for more generic mechanisms, is the versioning.
Yeah, the versioning is one aspect of it, but typically versioning means, I have some function, then I have an updated version of the same function. But if I have a different function that still falls under OAM for DetNet, then, so I think it's useful to step back and think how you want to do this, so you can have versioning, you can have multiple sort of sub-functions. It's an offline discussion, but I think it's one worth having.
Okay, thank you.
All right.
And we'll probably have more discussion, so welcome to DetNet meeting this week. And I think that will be last slide, or last substantive slide.
Okay, thank you very much. Our next speaker is going to be Kiriti. So let me load his slides. And Kiriti, you're doing the first nibble first. There we go. Kiriti, take it away.
Can you hear me?
Yep, we can hear you fine.
Okay. I just got a message from MeetEcho that my audio was not visible or audible. Okay, so yeah, I want to talk about the first nibble. and several issues that we have with it. So next slide, please. So the MPLS first nibble is the high-order 4-bit field of the first octet after the last label in the label stack. So you parse the label stack, you say, oh, here's the label with the end of stack bit or the bottom of stack bit set. Okay, the first thing that I see after that, take the first octet, take the high order 4 bits. That's the first nibble. And it became special for a few reasons. First thing that people started using it for is for load balance. We'll get into that. So the point is that that first nibble became important. And so what and there have been a few RFCs that have dealt with it indirectly. So what we decided to do is to step back, look at what it's being used for, look at how it should be used, and then based on that, make some recommendations. And so we want to come up with a requirement and a recommendation on the use of the first nibble, and stuff around that. We want a registry for first nibble values, and we want a registry for post-stack data. So sort of the first nibble also is used for to tell you what is going on in the packet. So next slide, please. So just to make sure we're all on the same page, here you see ahead of, on top of the label 1 that you see would be a layer 2 header saying this is an MPLS packet. Then you see a bunch of labels. You see the last label with the end of stack bit set to 1. The first nibble after that is what we're calling the MFN or MPLS first nibble. Next slide. So there are two cases. In one case, you actually have the payload, the actual packet being carried over MPLS directly after the last label. This is how a lot of things started when you were doing MPLS for traffic engineering. You took an IPv4 packet and just stuck it in there. When you did MPLS for VPNs, IP VPNs, which came first, you again did the same thing. So you had a bunch of labels. The last label might just be a traffic engineering label. It might be a VPN label. And then you had a V4 packet or a V6 packet. So that's the case on the left. The case on the right essentially says, oh, wait, I want to put some extra metadata before I actually start the packet. So the case on the left, you also could have had a layer 2 packet. You could have had an Ethernet packet saying, I want to do a pseudowire, or I want to do VPLS. I'm going to give you a bunch of labels. The last label is my VPN label, my VPS label, my pseudowire label, and I've got a layer 2 packet. In some cases, we said, no, we want to put a header in front of those two. So typically a control word. And so then we said, okay, if you're going to put a control word, that'll help with a few things. For example, let's not use the first nibble being 4 so that someone who's looking at this won't mistake this packet for an IPv4 packet and try to do some fancy load balancing on it. So then that's where we started putting a post-stack header, which is what I'm going to call it. So control word, OAM word, or words, a bunch of sort of extra metadata before the actual payload starts. So those are the two cases. Next slide, please. So why are we talking about the MFN? Why were people using the MFN? Well, the first reason that they were using it is as a heuristic. Can I tell when the packet, when the payload is actually an IP packet? Because if I can see an IP packet, I can extract fields from it and do better load balancing. Otherwise, I load balance on the transport label, or maybe the transport label plus a VPN label. And I get some load balancing, but not very good load balancing. So that was the first heuristic that people were using. And then the second was kind of sort of, let's use it also for the type of post-stack data that's carried. So The heuristic number one works for the case on the left in the previous slide. Heuristic, or the indication of the type of post-stack data, works for the case on the right, where you put values that are different and then say, oh, this is going to tell me something useful about what kind of data I have. So essentially, that post-stack data start off being control words. Initially, the pseudowire control word, then a DetNet control word. But now it can also be a beer header or a GACH or something. So you know that there's post-stack data in two ways. One is it's signaled in the control plane, hey, I'm doing DetNet. As Greg just said, DetNet must have a control word. So look for it. Or, hey, I'm doing pseudowires and I have this option to carry a control word. I'm using it, so expect a control word. For beer and for GACH, it's actually heralded by a label. So there's a gal label, excuse me, or there's a beer label that says what comes next is a post-stack data, which is of type beer or of type GACH. So there's a combination of there's stuff in the control plane that tells you that this is happening, and then there's stuff in the data plane that tells you that this is happening. Next slide, please. Things are broken, and the biggest problem is that you can have any kind, in principle, you can have any kind of layer 2 packet following when I said there are two cases. On the left, you can have an IPv4, IPv6 packet, or you can have any kind of layer 2 packet. And if it's a layer 2 packet, you're going to do potentially bad things because you'll interpret, in the cases where the first nibble is a 4 or a 6, you'll interpret the packet as an IP packet and try to load balance on fields that are not meant for load balancing. So the heuristic can fail badly. Now, given that we said we want things to continue working as they are, we have this big caveat, but that should continue to work. But at the same time, to the extent that we can prevent confusion of an IPv4 or IP version number with the MFN, we should do that. And we have new and better ways of load balancing packets, so we should start using those as well. Next slide. So these are echoing what Matthew said up front. We want to allow current implementations to continue working, even though there may be some heuristics that are less than ideal. I think we should point out that there are these issues, but hey, if you have an implementation today that looks for the MFN and tries to load balance on it, keep going. But we should lay the groundwork for better, more efficient implementations and lay the groundwork for easier identification of the PSD when there is PSD. And to the extent that we can make it self-contained, so much the better. Next slide. So in the case of an Ethernet payload, the MFN, if it is carried as a naked layer 2 over MPLS, then that first nibble is part of the destination address, is part of the OUI. It can take any value, and so there are RFCs that say you really should have a control word, but I think that's weak, and we should actually go on to a must. So we'll talk about that in a second. The current PSD types, when we say here's a control word, we're staying away from 4 and 6. But even there, we're saying, okay, we'll use 5 for beer and we'll use 1 for OAM. But what if there's a new version for IP that is like 7, or maybe they want to reuse IP version 1? What do we do? It's like, let's not even go there. Let us stop confusing the IP version number and the MFN. And so again, for backward compatibility, if you see a 4 or 6 and you want to try to recognize that as an IP packet and do load balancing, go for it. understand the problems that you can have. But if you see any other value, even if there's a new IP version 1, please do not use 1 as I can go look for IP packet or IP headers, or do not use 7 for that. So let's decouple the MFN and the IP version numbers. Next slide. Okay, so we want to be careful also not to try to backdoor an MPLS protocol field in here. So the MFN kind of sort of was used as a protocol field, at least to recognize IPv4, IPv6. Yeah, okay, we will leave that in for backward compatibility, but no more. What we will use the MFN for is to identify the type of post-stack data. So 0 means a control word, 1 means OM, 5 means beer, and so on. This is why we need a registry. So that's what we're going to do, right? The other thing we're going to do is to say, for all non-IPv4, non-IPv6 payloads, there must be a PSD. There must be this kind of header that says, I have a control word. It might only be, I'm going to put something non-0 here, non-4, non-6 here, but other than that, I'm not going to do anything else. And so if you do that, then you're not going to have any confusion of non-IPv4 packets being treated as IPv4 and load balancing happen there. So there's a recommendation for this, but we're trying to make this a requirement going forward. So existing implementations, yeah, they'll do what they do, and they understand the sort of what trouble they can get into. There is a recommendation, so that's a more like a requirement. There's a recommendation that for load balancing purposes, don't even look for those things. It's actually a lot more efficient to use a fat pseudowire or an entropy label, and you actually get much better load balancing. You do less work and you get better load balancing by doing that. So the recommendation is to use fat pseudowire or entropy labels for load balancing, and it works for more than just IPv4. And the mandate or the requirement is going forward, implementations can only have a naked payload of IPv4 and IPv6. Any new versions of IP or any other layer 2 or layer 1 packet that's carried here must have a post-stack data. The other thing that would be nice, I think, is to keep the recognition parsing of the PSD completely in the data plane. So again, we'd like to create an MFN registry. Today, we have an overlap between 0, which could be a control word for pseudowires or for DetNet. You have to resolve that in the control plane. But to the extent that we can, if you say, here are unique registries for different types of post-stack data, then I think whoever's doing whoever's trying to handle this in the data plane has a better time, has an easier time. Next slide. So, like I said, existing implementations can continue to be used with the caveats that we've mentioned. Pseudowire and DetNet control words will work as is. No changes are to be made to them. Or if there are changes made, like Greg was suggesting, it is in the context of stuff that they're working on. The one that I think is much more difficult is the GAL, ACH, post-stack data continues as is. The beer one probably will continue as is, and that particular MFN will be used for beer. Any new ideas for PSD should have a new MFN code point. So, this idea of reusing existing code points and saying I'll signal it in the control plane, to the extent that we already have it, we keep it. But if we can say going forward we won't use it, then I think people who write microcode will be happier. On the other hand, as we were discussing with Greg, we have a very small space for the MFN. So it would be nice to say new code points for MFN are followed by a sub-function registry as well. And that way we can extend the MFN. But that problem does have to be tackled. So, but we need to, for a starting point, we need an MFN registry and corresponding code points. Next slide. So here is sort of a proposal. This is not in the draft. The draft is something that we came up with. I should have mentioned this. There are several of us who talked together about, that we need a registry for MFN and what all should go into it. But in the offline discussions, and these thoughts that the MFN space is really small, we could have something like, you have an MFN that's 4 bits. Existing MFNs, yeah, they are what they are. But new MFNs, you might introduce a subtype. What Greg was talking about is a version number. So something that says I can extend the MFN space a little bit, so I don't have to burn a new top-level MFN bit for every new type of PSD. You also have a total length of PSD field, and after that you can do what you want. And that allows people that say, I don't know too much about this, or I don't care too much about this. I want to know where the real packet starts, and the total length of the PSD will say, if you don't want to process the PSD, just go on to the end, and there's your customer packet, and forward that as you need to. So this is, like I said, just a proposal, but it captures 2 important things that we need to tackle. One is, how do we make the MFN space bigger? And 2 is, how do I skip the PSD altogether and get to the customer packet? And beyond that, I think the PSD should be self-defining. Questions?
I'm in line.
Okay.
Okay, I actually had a quick question just based on your last slide myself.
Yes.
I assume that will be in the next revision of the draft.
Yes.
Okay, very good. Let's move on to Hayu and then Loa.
My question is that I think the use of this first label is to avoid ambiguity due to the lack of any effective indicators in the label stack. But from now on, if we are designing this ancillary data, we need to define an indicator in the label stack. If we have that in place, then it seems it's why we should care about this first label anymore, because we know for sure what follows the label stack. So that's my question.
So that I try to tackle that in my next presentation, but I agree with you. I think there's place for things in stack and there's place for things post stack, and I think we have both levers in our hands, and I think what we should come up with is the ideal, or from what we see now, the best possible view going forward. So I'm with you.
May I, or?
Actually, Lo, what was next? Even though we didn't put his hand up, he did turn on his microphone.
Oh, sorry.
Okay. Let's see. So I have one thing. I'm kind of supporting Hayu on that we actually know from the flag field what actually follows. But even if we didn't do that, why couldn't we just increase the subtype to 8 bits? It would work just fine.
Sure. Yeah. So this, like I said, this is currently just a proposal.
So what you do is you take one MFN field or value. Only one, and then you have 8 bits to actually diversify it.
Yes.
Go ahead.
Yeah.
So the pseudo-wire control word has those 4 bits for that sort of purpose. It was actually intended for version fields, but they are qualifier bits that are available and were always in the design.
Right. And so I think where we are kind of going is maybe every MFN would have such a qualifier, and you know, everyone going forward might have 8 bits, but the ones that have already defined it, you know, in Greg's thing, he had 4 bits for a version number. As Stuart just mentioned, we have 4 bits for a qualifier. I think going forward, we might say every new MFN would have 8 bits set aside to expand the functionality. So we group more things under the one top level 4-bit field, and then say, okay, here's how you know which one of those it is in the second 8-bit field. So I think we're all saying the same thing. The one thing we didn't talk about is the total length of PSD, which I don't think people would disagree with, from the point of view of being able to skip the PSD and knowing where the end of the PSD field is, so I know where the packet starts, the actual payload.
Yeah. I actually think creating it'll be much easier for people to discuss once there's a concrete proposal on paper that they can all look at and comment on.
Yeah, no, I agree. I will bring that up as soon as this IETF is over.
Okay, and Wim is next.
Yeah, so my questions relate to the same thing. As far as I understand, the PSD can it's ancillary data, but potentially could have multiple contexts, if I'm understanding it correct. And as a result, don't you need the MFN to indicate which piece is what?
So, very good question. I would like the PSD to be self-describing. You know, in stack data, you have very limited space. You want to try to fit everything into 32-bit chunks, and it's not even full 32-bit chunks. So what you end up with is you don't use TLB structures there. You use the indicator flag structure there. In the PSD, after this first sort of header that says, this is my MFN type, this is my subtype, this is the total length, then you sort of say, okay, now you have a TLV structure. It could be a TLV, it could be next header, it could be whatever structure you want, but it's self-describing. And so you're able to parse it, you're able to do multiple functions. You know, some of them might have a lot of data. The in-stack, in-situ OAM could go in there. A bunch of other things could go in there. And so the PSD, you know, it's a free-for-all thing. And so you have the TLV structure or TLV type structure. And then, of course, you have your payload. So, you know, I'm leaving it open to that. I think we're in agreement.
Yeah, no. I think, yeah. So, but I'm trying to make a point that we need somehow an MFN of some sort to indicate also potentially for the order, right? I mean, or because depending on the use case, it might matter which part of the PSD comes before the other. I don't know. I mean, it's hypothetical.
Okay. You have a very good point. So this is one of the things that the IPv6 guys also struggle with. So the idea is that there is one MFN, right? That's the first nibble, and it says there's PSD, and that's why there's a total length of PSD. That total length of PSD can be broken up into, let's say, TLV structures. I'm not wedded to TLV, but let's just say, because I like to work in something concrete. So I can have multiple TLVs there. So I can have something that says, this is in situ data, the length is, you know, 30 bytes, and now here's the value. And then there's something else that says, this is, I don't know, some other PSD data, the length is 16 bytes, and here's the value. So I have all of those. Now, organizing those and putting them in the right order is really important, because you're processing these in the data plane. And if you run out of time, you know, if you process them sequentially, then you'd like the important ones up front. That is a second order issue that I don't want to get into, but you don't have a new MFN for each of these. I don't think that we need to burn a new MFN. We have one top level header that says, here's the type of MFN. So let's say MFN value 9 is, this is the new MEAD generally extensible MFN, post-stack data. Here's the subtype, here's the length, and then you have a bunch of new things. To your point, when you totally need to put them in some order, but that is a second order question.
I think so Katie, my point is just there is a few considerations we have to take into account, right? We don't have to solve it right now, but I think it's good to list them somehow, and maybe some of them are not important, some of them are, but I think it's good to list the things we should consider for this and then see what would be the best solution for it somehow, right?
Yeah, okay.
Yeah.
Okay, I've closed the queue because we're starting to eat into the time for Creedy's next talk. So for Greg and Stuart, if it's really, really short, we can do it now. But otherwise, I'd like to ask you to wait for the discussion period. So
just a statement, not a question. I get very good feeling that it might look similar to IPv6 extension headers, and that's something that we can discuss on a list. And actually, we have advantage because they suffered their pains and got their cuts, so we can learn from their experience and see how we can apply it to what's at task we have at hand. Thanks.
Yep, agreed.
So just quickly, something that the working group needs to be under no illusion about is that there will be random raw Ethernet packets floating around the networks for the foreseeable future. There's no way of forbidding them. And in any network where that they happen, then you can make no assumptions about that first nibble. So as a way of organizing stuff, this is fine within the scope of the work we're doing. But I am really worried if anyone makes a serious forwarding decision based on one of those, on the meaning of one of Creedy's MFNs, without many other qualifying things that tell them that this is not a regular Ethernet packet they happen to pick up.
I agree. I think the fact that we allowed, in the beginning, we said there's not going to be a protocol field in MPLS, and you could carry naked packets after the label stack. Kind of bind our hands a little bit, but we need to move forward.
But I don't see how we can move forward and abide by the other important principle that we've always had in MPLS, which is that we don't obsolete any existing LSPs.
Right. Stuart, we really do need to move to...
Yeah. We'll discuss it at a later time.
Sure. Okay. So thanks, Andy, for the next slides. So here, this is about the forwarding actions indicators. So next slide.
Wait 1 second.
Yeah. So there was discussions both in and outside the OpenDT, the Open Design Team, regarding the ISD and the PSD. And so I thought it would be a good place to bring this together. So some of the questions were, when should some indicators or data be in the ISD versus the PSD? And we've had a little bit of talk about this, but maybe not enough. So I think we need to do more of that. The other is what should be said about the PSD in the ISD. So in the in-stack data, what do I say about the post-stack data? And one big consideration there is that in-stack data is much closer to hand, typically, than the post-stack data, which you have to parse the entire stack to get to. The third one is what about extensions? I mean, the very first version had 7 or 8 indicator fields sort of present. There was a field that said, here's how you extend it, but we hadn't gone into details about that. So what if we need more indicators in the same FAI block? And then another discussion was around what about standard indicators that someone doesn't understand? And then what about non-standard indicators, sort of user-defined or provider-defined indicators? And I think that would be a very nice thing to add, but how would you handle it? So So, sort of trying to bring all this together, if you go to the next slide. Let's start with the philosophy of the ISD. The ISD is data that you want to process with some urgency. You're willing to live in a more constrained environment. You're trying to fit within, ideally within a single label, including the TC, TTL fields. So you want to encode this very compactly. You want to process it pretty quickly. And you must respect the bottom of stack bit because you are still looking at what theoretically seems to be a label. So the in-stack data, you want to be very careful with, parsimonious with, and you want to process it quickly. Next slide. The post-stack data, you have, your label stack is over. I mean, you've hit the bottom of stack label, and now you can be a lot freer with things. So it does not have to be ultra compact. You still don't want to carry, gigabytes of data in there, but it doesn't have to sort of fit into, I look like a label even though I have all this other information. You don't have to respect the bottom stack bit. So it's a lot easier to work with. Ideally, at least I think it should be self-describing, so a TLV type approach, and we can have the discussion. Is it a next header? Is it a TLV? Is it something else? But that is reasonable. We now have more space to work with. So given this, we don't have to put too much information in the ISD, in the in-stack data about what's coming after the post-stack data. And if you put a lot of information there, it can also lead to confusion. If the in-stack data says, oh, and by the way, expect in situ OAM, and I'm just picking that as the first thing that comes to mind, in the PSD, and the PSD doesn't have it, that what am I supposed to do? Or if it says there isn't any in situ data, and then suddenly when you're parsing it, you find it. So it's probably better not to repeat those things and lead to confusion. Next slide. So one suggestion is the indicators should only say who should look at the PSD. It's an optimization just because the PSD is so far away or potentially far away. And so the worst case is that every hop looks at the PSD, which means you scan the entire label stack, you come to the bottom label and say, okay, now I have the PSD, I'm going to scan it and see if there's something interesting. But ideally, you could optimize that away by saying, I'm going to use 2 bits, 0, 0, meaning you could go look at the PSD, but you don't have to. 0, 1 saying, if you want to, you can, but if you're the egress, you must. And in a sense, that's kind of a overkill because the egress is going to see it anyway. If there's 1, 0, every hop should look at the PSD. And then if there's 1, 1, every hop must look at the PSD. And this goes back to what Matthew was saying in terms of these are the things that I don't want to send to a node that doesn't know how to process it. The other ones are, well, maybe 0, 1 about the egress, but that's only the egress. If you think about the hop by hop thing, and if you have a must, if you don't understand this, you're going to drop the packet, then don't even route it over nodes that potentially won't understand it. So this is a suggestion that you have these 2 bits in the ISD that tell you who should or may, should or must look at the PSD, but it doesn't tell you anything more than that because you're going to look at the PSD when the time comes. If you have cycles to do it, etc. You really want to process the ISD because that's what's much more immediate. Next slide. So there's this whole other thing that we were talking about, handling extensions. And so there was, in the first version, in the 0.0 version of the draft, it said there could be extensions, but didn't talk about it. In version 1, we started trying to put more into it. So the idea was to put an EBIT that says if the EBIT is 0, that means you're done, and if EBIT is 1, that means there's more bits, and the next one would also have an EBIT and so on. So you can keep processing indicator flags until the EBIT goes back to 0. So it's sort of, it's an inverse of how the bottom of stack bit works. And so I decided, what if we flip it, and then we can reuse this bit for other things? So because we have this question of, here's a standard data field, but maybe we have 20 data fields, but a particular implementation only understands 3 of them. How would it know when the data is over and the label stack continues as usual? I decided, let's invert this and use this bit for more than just extensions. So next slide, please. And this was a result of lots of different discussions, both in the working group and outside the working group. So the current thing is that you have this bot. Well, it's not the current. If you flip the E bit, you have something that says this is the bottom of indicators. So if you flip the current meaning of the E bit, as long as it's 0, that you have more, and when it says 1, you're done. So if you have a very, very simple FAI label with just 3 or 4 indicator flags, the very first one would have the 1 set. But if you have more, you put 0, and then you have more bits, and then if you have even more, then you put 0 again, and then finally you say 1. You say, okay, I'm done with the indicator section, the flag section. So you can see on the right, that's the flag section. So the next thing you have is the standard data. Corresponding to those flags, I have this data. So there might be entropy label, there might be a slice identifier, there might be whatever other standard data we have. But again, you might have a problem that someone says, where it starts is pretty simple. It's where the indicators end. Where it ends, well, I don't know, because I know only how to process these 2 bits. And so I get 16 bits or 32 bits or whatever. And then after that, if there's more, I have no clue. So what do I do? And we don't have a TLV structure. So how do I manage that? So you can do that essentially by taking this idea further. So next slide, please. Yeah, I'm just saying that again. What if there are 50 standards fields and I only understand 5 of them? How do I deal with that? What if there is user-defined data? How does an implementation know where it starts and where it ends? So let's reuse this bottom-off kind of thing, and for all these purposes. So the next slide, please. So this is what it would look like. So in parallel, you can see the end of stack bits, which are going to be all 0. There'll be some labels in the front, some labels at the bottom, and then the last label, which has the end of stack or bottom of stack bit set. And then you have this thing that is the bottom of section bit. And so in this one FAI block, you have 0, 0, 0, 1 that says, okay, these are indicators. Then the meaning flips and it's 0, 0, 0, 1. That's the standard data. So standard data starts when the indicators end till the standard data bottom of section bit goes back to 1. And then you have 0, 0, 0, and then 1 that says this is user-defined data. So if you reuse that bit, then what you basically have is 30 bits per label that you can play with for anything. And the end of stack bit is completely, has to be preserved, just so that your label stack, the entire label stack, is sacrosanct. And then you have this end of section bits that tell you, I've got the indicator section, I've got the standard data section, I've got user-defined data. Again, this is just a proposal, and I know Andy will say, write it down so that people can throw things at it, and I totally agree, but I wanted to present it here so that people have an idea what's coming up. Next slide, please. So here's just a quick view of someone who is looking at this. The crosshatches that are top right to bottom left in orange are things you understand. The crosshatches that are top left to bottom right in red are things you don't understand. So if you look at the first FAI label, it has these 11 bits that you should be trying to work with. And you understand some of them, but not all of them. There's some extensions. So you said, fine, I'm going to process what I understand. I'm just going to skip the rest. I know that when I get to that B bit equals 1, then the flags are over. and then I start processing the standard data. I only understand a little bit of it, but I know if I keep processing until the B bit is 1 again, standard data is over. I do understand a little bit of the policy stuff or the user-defined stuff. Again, I know when that is over, and so I have come to the end of the FAI block. So by reusing that 1 bit, I can break up my FAI block into the flag section, the standard data section, and the user-defined data section. And again, this is just an illustration of how this proposal would work. So questions, comments?
Thank you very much, Quiddy. I actually have the queue closed, and the reason is that we have to move on to John's talk. But if people have any questions or comments, please wait and write it down, and then you can ask it after John's talk. So with that, John, if you take the mic, and I will put up your slides. John, are you there? If Adrian told me that John was having issues, so if John, if you're still having issues, then Adrian, can you speak?
I can. So I think I will. All right then. Wait, John. What is his hand up?
Well, John has his hand up. John, can you put your audio on?
Yeah.
Okay, there we go.
I'm sorry, I was logged out and I was in the middle of logging back in again.
Okay, John, then you can take it over.
Okay, next slide. Okay, first thing is this work on network functions is derived from Curity's drafts, where you basically have a special purpose label and then a bunch of bit flags that identify forwarding actions. And what Adrian and I are trying to do is basically just generalize it and flesh it out. And so we are using the term network functions rather than forwarding actions. We have 2 special purpose labels. One is hop by hop and one is end to end. And the P nodes only look at the hop by hop special purpose labels. This was a suggestion from both Adrian and Stuart. And basically it allows both types of network functions to evolve independently without any interference. And both are completely extensible. And we are not changing non-label fields in the SPLs. And then what's going to happen is when you define a network function, it's going to be defined in an RFC of some sort. We define whether it's hop by hop or end to end, what bit it's going to use in the network function flags, which I'll describe below, and whether it has ancillary data. If it does have ancillary data, what is the ancillary data? Is it in stack or after stack? So that you basically will know, you don't need any indicators, you will know all of the characteristics of the ancillary data just from its definition. Next slide, please. So we have this network function label stock block, which is an SPL, network function flags, and in-stack ancillary data. The SPLs we already talked about. The network function flags is basically it's going to be basically a registry, and whenever we define a new network function, we're going to define a new bit which identifies that network function. It's in a set of 1 or more label stack entries, and we have a continue bit which indicates that there's another label stack entry with network function flags in it. Then the ancillary data is 31 bits of ancillary data for each network function whose network function flag is set, and the ancillary data is in the same order as the network function flags. And we had said that it was delimited by another SPL or label stack entry with bottom of stack or ancillary data with bottom of stack. There's actually a couple changes that have been made in conversations with Adrian and Stuart over the last couple of days. One is that there's no reason that we couldn't have 2 or more label stack entries for a given network function. And the other thing is that we probably want to add the continuation bit for the ancillary data so that we will know precisely, even though that doesn't understand the ancillary data, we'll actually know when the label stack block ends. Anyway, at the bottom, there's just a picture showing what it looks like. Next stack, please. And the way it's going to work is that the network function flags are in order, and a given node will understand the network function flags up to a given bit position. It doesn't need to support them, but it understands what they are and what their ancillary data looks like. And so this allows the node that doesn't support a given function to just skip over the ancillary data for that function. And then the label stack block is terminated for all the function flags greater than n. Basically, the label stack block goes opaque when a given P router doesn't understand any additional network functions. And so what that means is there will be basically a given set of network function flag, a set M, whose network function flags are set and understood by that node. And so that basically says the size of M is less than or equal to N. And then within M, there's going to be three sets. There's a set X, which is network function flags without ancillary data, network function flags with in-stack ancillary data, and network function flags with after-stack data. And so basically, you will have a set of network function flags that are set, and then you will have the in-stack ancillary data for those network functions in the stack in order, and then the after-stack data is in the same order as the network function flags that were set in the packet. And obviously, if any one of these sets is empty, there is no ancillary data of that type. And that's it.
Okay. Karidi, you have a question?
Of comments. One is, if you have a special purpose label that says this is hop by hop, and another that says this is end only to be processed by the end nodes, how am I supposed to know that if I haven't reached that position in the label stack?
I'm sorry. Please repeat the question. One of our dogs is barking.
Okay. So let's say that I have various labels. Maybe they're segment routing labels. So there's like 5 labels, and then there's an SPL down there that says I have data that should be processed by every hop. Or you have a similar situation where you have 5 labels on top, but I have data that is, really interesting end to end. I have to come down. I can do my forwarding just by looking at the top label, but I'm going to have to come down to look through the stack and say, is this interesting for me now, or is this interesting for me only if I was an end node? Is that how you're seeing this? That I have to parse the label stack anyway, looking for these SPLs and say, oh, this is the SPL that is applicable to me as a P router, or no, this is only SPL.
What we said was the hop by hop SPL always precedes the end-to-end SPL.
Okay. But you have to go through the label stack looking for the hop by hop SPL.
Yeah, well, that's the same as your proposal.
Yeah. No, I'm just trying to understand. So even for the entropy label back in the day, you'd have to go through the label stack looking for the entropy label indicator. Okay,
that's correct.
So,
like I said, this is basically an attempt to generalize and fill in the blanks with your proposal.
Yes, I'm trying to see what is different, and there are a couple of things that are different. One is, in my proposal, I don't want anything that is end-to-end to be, try to fit itself in this label stack format and keep the label end of, the end of bottom stack.
What we said was, if it's related to forwarding, it should probably go in the stack. If it's not related to forwarding, it probably shouldn't go in the stack. But we make that decision. We make that decision when we define the network function.
Well, so the first thing is this whole thing about network function. I object to that simply because if it's related to forwarding, I don't want people to think, oh, I can put in some Turing computable function in here. I just want an action that I do right now. And yeah, this is more like maybe marketing or something, but by saying function, you're talking about things that could be heavyweight. By saying action, it's like something I do now and move on. But
then fine, we could call it network actions is good.
Yeah, but the higher order bit is the way that I had defined it is there are these forwarding actions that are going to be encoded in the label stack. And then there's going to be a bunch of other things that you want to do that you'll encode in the post-stack data. and so if it is not hop by hop, put in the post-stack data. And if you're putting in the post-stack data, then you end up with, all I'm going to tell you is whether you need to look at the post-stack data or not. And so I can put things that are hop by hop in the post-stack data, but post-stack data is generally end-to-end. But anything that I need to do on a hop by hop basis, the majority of it I'll try to put in stack data. So it's not like there's in-stack data that is hop by hop and there's in-stack data that is end-to-end. It's in-stack data that is hop by hop, always. And then there's post-stack data, some of which is hop by hop and some of which is end-to-end. That was kind of where, yeah.
That's completely consistent with what we're proposing.
Right.
Okay.
I'm just saying that, yeah. Okay.
I would like to give other people a chance as well.
Yeah, sure.
So
I'm done.
Okay, great, thanks. So Tariq, you're next.
Thank you. Thanks, John, for proposing this. Many of the things, I'm okay with. I just want clarification on the flags and the metadata post-stack data. Sometimes a flag might be present in the function flags, as you call them, or forwarding action flags, but the metadata is missing for that type length value or whatever we come up with. Like the data associated with that flag is not in the post-stack data. Would this be considered as invalid packet in that case, or this is something we need to still define?
I think when we define a particular network function, we specify this as an additional part of the behavior.
Yeah.
For some, I actually like network actions now. I think that's good. But for some network actions, for some reason, the ancillary data just didn't get put in, but that's okay.
Oh,
for
okay.
another network action, throw the packet away.
Okay, thank you.
Okay, thank you. Stuart, you're next. Stuart?
A couple of things. Yeah. You have to give permission for the browser. I'm sorry, I forgot. I'm sorry if I'm irritated. All right. So, a couple of things. First off, if this indication that's in the stack, information that's in the stack, it's inconvenient to put it right at the very top of the stack. For example, in segment routing, then you may consider an indicator for the presence of an indicator, which may be either a real indicator or the use of a FEC that says whether it's worth searching for anything of interest further down in the label stack. So there are other toys that we've got to bear in mind. In terms of end-to-end data, I think Kariti sort of said it, but I want to be absolutely clear. Above the top of the bottom of stack, there has to be some indication that this stuff is below the bottom of stack. Otherwise, you could never find it there.
Stuart,
yep.
That is part of the definition of a particular network action.
Okay, all right. Now I want to just deal with one other case, which is people were assuming that data that you process hop by hop has to be above the bottom of stack. I think that's what I heard. But there's some types where
no, we did not say that at all. When you're defining the network action, you specify what is the ancillary data and where is it.
Good, because it has to be the general case. I think someone suggested that it wouldn't be. Maybe it was Kariti, and maybe I
no. I
misspoke.
mean, what I said was
right. So here's the case I am worried about.
Can I just answer, Stuart?
Yeah.
There is definitely hop by hop PSD.
Yep.
And there is end-to-end PSD.
Yep.
What I did suggest is so what I did suggest is that the in-stack data is generally hop by hop. I mean, if you're going to put it in the label stack and live by those constraints, there's a reason you did that.
So it's the generally, I think, probably is the get out of jail card here. There is some data that I really don't think we would be likely to want to put in the stack. For example, the IOAM hop identifier, or some latency-based forwarding information that took significant data. So I think we need to be careful here. Some data may go in the stack, but some hop by hop data may be forced to go after the bottom of the stack simply because of the size of it.
That's right. And what happens, as I said, when we define the function, we specify what the data is and where it goes.
Good. Okay.
So if I look at the difference between this proposal and the original FAI proposal, essentially the FAI proposal says everything that's in stack is hop by hop as well. There is nothing that is end-to-end that is in stack. Everything that's post-stack could be hop by hop or could be, so if you take those four combinations, in-stack hop by hop, in-stack end-to-end, post-stack hop by hop, post-stack end-to-end. FAI says in-stack hop by hop, no in-stack end-to-end, post-stack hop by hop, post-stack end-to-end. What I understand this proposal is saying is you've got all four combinations, and I don't see any reason for putting end-to-end data in the label stack. Put it after the label stack. Let the label stack be done with. When you get to the egress, you're ready to handle the post stack. So that's the one piece of this that I don't get.
Okay. Except of course the indicator that the post stack data is present. Yep.
I mean, there may be a case where we want to have end-to-end data in the label stack. When we define a network action, we will say, what is the ancillary data and where does it go?
With that as a general approach.
I have a general comment that as a principle, we should avoid to continue to complicate the label stack. Once we have a clear design how we organize the ancillary data, we can just put them all up to the label stack. I understand there are some legacy designs which use the labels, but we just keep that as is, and we should continue to add more on that, because I'm saying that because recently I'm doing a lot of research on actually write the parsers for the different style of header design, and I find all those complications in the label stack it doesn't help. Most of the times, it just makes things more complicated. It doesn't help to improve the performance. And also, it introduces a lot of constraints and limitations to the design.
Well, one of the things that we stipulated in the definition of the process for evaluating proposals is that proposals are checked with the hardware designers for the various vendors that are working on this initiative. That's part of the process.
Continue to do that. Yeah. Meanwhile, I have the hardware design background. I already done the
right, but you're not the only hardware designer.
Yep.
You're not the only hardware designer that's looking at this stuff.
Yeah, I'm just express my perspective. So that's all I got now for now, right?
Okay, and Loa has a question.
In that there is data that you need to put in stack that you want right there so you can process it pretty urgently. So for example, a slice identifier. You cannot treat a packet correctly if you don't know what slice it belongs to. And so you want to see that slice identifier right there so that you can actually do that. Anything you put post stack, you have to parse the label stack to get there. And that can be an onerous task for every hop to do. The entropy label, I know you were saying a legacy. I don't know that I would consider this legacy, but the entropy label is not, you have to do it, but you can do a much better job load balancing without going to the end of stack and figuring out what's going on there, because you have a nice hash right in front of you. So there are things that you need right there, and there are things that you can say, I have to wait, or the things that you say, I don't want to wait, but I have to because there's so much work to do here.
Okay.
So,
Loa is next in the queue, Greedy.
Okay, so I just one small comment, and that is that because you can do something, it's not necessary that you do it. So if there are data that you normally don't want to put in the stack, then you don't do it. But there are 4 alternatives, and we should cover all of them.
Right. And as I said, when we define a function, we define where the data goes.
Okay. I don't see any current hands up at the moment. Loa, just
I'm
stand
back,
back up.
yeah. It's something different. This is more a working group share position. I'm concerned about, we have 8 base SBLs left. And if we take 25% of those for handling the indicators, then I'm concerned because I'm getting on the low side of available SPLs.
Loa?
Yeah.
I mean, once we have the 2 SPLs, then we can basically the hop by hop and end-to-end functions are pretty much extensible without any more SPLs.
Well, what's not extensible is the base SPLs. We will run out of them sooner or later if we're not keeping a very strict regime on how we allocate them. So one thing is we should look at if we can do it as efficiently with just one base SPL. And I don't think it's any way around that.
So if I can comment, first of all, I don't see a reason to carry in-stack data, which is end-to-end. I mean, if it is not urgent for every hop to do, put it in the end of stack, put it post-stack. So having one SPL saying, I've got data that's interesting for everyone that's going to process this, and then having just bits that say there is post-stack data for everyone, or there's post-stack data just for the end-to-end guys, or there's no post-stack data. I think that is a single SPL that you need, and it covers. I mean, yes, we have 4 cases, but I don't think all 4 cases are valid. In-stack data that is end-to-end is a waste of in-stack data. That's my view.
So that I made to John that I think maybe I could encourage people to think about is whether we need physical definitions of these bits or logical definitions of these bits. So this is MPLS, right? And MPLS gets around a lot of these resource limitations by mapping through the control plane. So you could have an LSP wide or even a network-wide set of mappings between the functions and the physical bit that they will occupy in the network, and that would reduce the number that we needed. Also, I am sure that if we think a bit harder about the encoding, we can probably get down to one SPL for both functions.
Okay, and Adrian has his hand up.
Yeah, thanks. I just wanted to wonder about Kariti's point there for end-to-end data, because I think end-to-end can be blurred a little bit, where it's a routing operation that has to take place at the final router. I think of pop and go type operations, and there it's not quite clear to me whether this is sort of the end-to-end data that you put after the stack because it's what you do after you've written the label, or it's end-to-end data that you do because you are at the end of the path and you're about to rip the label. Just thinking.
Adrian? Yeah. There also, I was talking with Joel, and there's also another case which may be of interest, which is that it's neither hop by hop nor end to end, but it's really the router that pops the label at the top of the stack. So it's sort of between intermediate points along the path.
I see what you mean. End of the tunnel type of end to end rather
Correct.
than end of the whole MPLS end to end. Yeah.
Okay. Loa?
So one thought on this. When we did MPLS TP, we worked with MIPS and MEPS. And if I understand correctly, MIP could be actually allocated anywhere along the LSP. Do we have something similar here?
That's what I was sort of alluding to in my response to Adrian.
Sure. So it's not necessarily end of tunnel or end of LSP. It could be middle of the LSP, but you actually want to address it.
Correct. And I think that there's been previous discussion about that in some of the proposals from Huawei.
Yeah, maybe. But I thought they were kind of MPLS TP.
In other words,
related,
I mean, it's an area that we can work.
So from my point of view, if everyone, I mean, when I say hop by hop, it doesn't necessarily mean everyone along the path has to process it. It means that, I mean, if you have this simple dichotomy into the end of tunnel and hop by hop, then for the hop by hop things, you're saying, and that's why I want to have a should and a must, right? If you have cycles and you can go down and look at wherever it is, you can process this, and you might get there and say, there's nothing really much for me to do here. If you know that nobody in the middle is interested or could use this effectively, then you say it's end to end. But the fact that you say it's hop by hop doesn't mean everyone on the hop, everyone on the path.
That's what we said on slide 3. That's exactly what we said on slide 3.
So then I'm struggling to understand what is, the fourth case. What is the case where you put something in the data, in the label, in the ISD, that is really only to be processed by the end node? Because, if it's going to be processed by some guys, that's hop by hop. And so what I'm basically saying is, you've got ISD that is end-to-end, you've got potentially ISD that is hop by hop, you've got PSD that is end-to-end, you've got PSD that is hop by hop. That first case, ISD that is end-to-end, don't even worry about it. So ISD is hop by hop, PSD is hop by hop or end-to-end. That's what the current forwarding actions talks about.
Adrian may
so Adrian? Sorry? Yeah, okay.
Yeah, so very quickly, Kariti's just reminded me of something that came up long ago in this discussion, which is whether it should be necessary to distinguish between actions that, functions that a router must operate on, and if it doesn't understand them, then it cannot forward the packet, and functions where the router is allowed to say, I don't understand it, or I don't want to operate on it, and can continue to forward the packet. That's, if you like, slightly orthogonal to the hop by hop thing, but I'm not sure we closed on that must versus can ignore.
Yeah, I touched on it in my slides, but yeah, we haven't closed on it.
Yeah, I think, Adrian, that we would just, that would also be in the definition of the network action.
It doesn't work in the definition, I think, because if you receive it and you don't understand it, you need to know whether or not you can forward it without understanding it, and you can't. If you haven't implemented the RFC, you can't know whether you can forward it without some additional information.
Well, we have to be we have to be able to incrementally deploy, which means that there are routers that are not going to understand all of the network functions. That's correct.
Hat on. We didn't take questions and beyond clarifications for the earlier pieces of this. We're running out of time. I think we need to give people the opportunity, if they want to discuss any of the points that we worked on during this session.
Anyone out there with any other questions or comments?
Yeah, I'm not trying to shut John's discussion down. I'm just trying to make it clear that people can discuss other things.
And I'm not seeing any hands go up. So I think we've reached the part of the meeting where I'm closing the queue for further comments. And we're going to move on to Stuart, so Stuart can give us a summary of what he's heard and where we stand and what's next going forward.
Right, so this is a particularly short straw. So firstly, I'd like to make an observation from the MPLS meeting that where Loa introduced a very important point, and that's that this is a body of work that turned out to be much deeper and more difficult than we had anticipated when we started. It's my opinion that we need to work a bit harder to, and certainly for longer, to bottom out this piece of work rather than just take the first things that come to mind, because the more we explore this, the more difficult it seems to be. Hopefully we will have some insights soon that will allow us to get to the end relatively quickly. So the requirements, they need to be studied. We really do need some, because they are the foundation of what we do and the decisions we make. And I think there needs to be more input in the ODT process on requirements. We need to find a way of giving them more quality time, and of course time on the list. Matters of how we encode the information in the stack, covered by both Kariti and by John, I think is going to need some, again, focused time, maybe more time than we can get from the weekly meeting, maybe a breakout group or something. But there are several areas actually where I thought we could do with some focused discussion, more than the sort of 10 minutes, 15 minutes we get in this session, and perhaps more than we can get in when we mix it with all the status reports and everything on the Thursday meeting. So I think there are a number of cases here where, and I would recommend that that we as chairs maybe set up some specialist discussion. In the old days, we would of course had an interim meeting on a bunch of this, but that's not really going to happen. I think there's something else that we need to discuss, which is the processing model, which was mentioned briefly by Hao Yu, but again is fundamental to some of the decisions we need to make, which is that we need to understand what an MPLS router looks like for the purposes of doing these and what constraints we're going to introduce. Now, hopefully we can do both that discussion and the detailed design discussion and the requirements, in particular the requirements, without this becoming a proxy fight for these solutions, because that is what always bogs down these sorts of discussions. So I think that's my summary of where we are and what we need to do. I'm more than happy to hear contra views from my co-chairs or from the working group. The audio, or no one had any comment?
Yeah, there was a comment from Lou in the chat about possible virtual interim, and we also have a comment from Tarek.
Stuart, do you think the weekly meeting that we're having for the open design team can fit into the breakout discussions that you'd like?
Well, I think in terms of process, it's very reasonable for the breakout discussions to report into the weekly meetings.
Okay.
I am just worried that 1.5 hours a week is not going to be enough to get our heads around all of this, particularly as some of these things, well, your thought model process may be different, but some of these things you really need to think about for a bit before you decide whether you agree or not. But I think there's no reason why we can't have groups reporting on the weekly meetings just to give a status update, rather than necessarily have to wait until the next free weekly meeting to do the detailed discussion.
Okay, I would like to give Lou a chance to make a comment. Lou?
Yeah, so if you need more discussion time, either schedule more informal meetings, or if you want to make it, formalize it, there's no reason we can't have one or more virtual interims.
Well, this is just me sort of feeding to my colleagues in the other chairs to say where my head got to when I looked at the depth of discussion that we were having.
So if I can jump in,
yes,
we've had several of our weekly meetings postponed for various reasons. I think we could fit this into our weekly meetings. If we really needed to, we could have more weekly meetings. I think the idea that we have our weekly, I mean, it's an hour and a half. And yes, we want to do 10 minutes of status and action items and make sure that we are on track. But we could easily have an hour in these weekly meetings where we have focused discussion on any particular subject, as opposed to try to say every weekly meeting there's 10 minutes for 10 different topics. So I think we can make progress in the weekly meetings. But to Stuart's point, it might be effective for some things to take them offline, but the problem is then you have it offline, then you have to bring it back to the main meeting. But making forward progress on this, I think, would be a good thing. But I think we also have to ask ourselves if we're using our weekly meetings in the most effective way.
It behooves the chairs to have a discussion after this to work out how we can get this volume of work done in a sensible time.
Sure.
Okay. Anything else? Going once? Going twice? Well, I'd like to thank everybody for participating. I think this was a really good session, and we'll see you all at IETF 113. Andy out.
Thank you, Andy. Bye.
Goodbye.
Dave. Bye-bye.
Goodbye all.
Were you asking me something? I guess not. Adios.